All right, so we're going to talk about solubility. And I'm actually kind of excited to talk about solubility because I think it's kind of a fun concept and there's distinct rules that we can use to help predict the results of a chemical reaction. What we're really interested in is, will that substance dissolve? So before we start, there's some vocabulary that we needed to get our brain wrapped around. So first things first, solubility is a substance's ability to be dissolved in a substance, to be dissolved. Specifically, we're talking about in water, but solubility refers to its ability to be dissolved in multiple things. So there's two parts to it. There's what we call the solute and what we call the solvent. Now, the solute is the substance that's getting dissolved. If I take sugar and I drop it in a glass of water and stir it up, the sugar gets dissolved in that water. The sugar in this case is the solute. The water is the solvent. In other words, the substance that is doing the dissolving. And it's these combination of things that make our solution. A solution is a combination of our solute and our solvent. Now, often there's times when a substance cannot be dissolved. And what we end up with is this solid form inside our solution. We call that a precipitate. So I want to show you some picture examples. Here's a little cartoon drawing. Here's our whole solution, but we can see down here, this solid that hasn't been dissolved yet, that's called our precipitate. And that precipitate is what we're going to be predicting here. So here's two test tubes of substances. You notice they've got nice bright colors. That's why I chose it. But they've got nice bright colors. But down here, we've got this yellow bit. So as we add this one of these is the solvent, one of these is the solute. But what we end up with here is we end up with this solid that couldn't be dissolved. And so what happened is when we mixed these two together, a chemical reaction took place. And when that chemical reaction took place, one of the new products could not be dissolved and it formed this solute here. So what we're going to do is we're going to do a couple examples. Now, in order to predict it, we need a tool. Now, what you see on the back here is our brand new data sheet for our periodic table. This took way longer than I think it should have. So here, I'll show you where you can find this. If you've got your old periodic table, this is still on there. I just think this one's prettier. If you go into Classroom, under our classwork tab, click on periodic table of elements, and right there is our brand new periodic table. So click on that, and you'll be able to get access to our new one. But what I want to show you here is I want to show you on it, we have what we call our solubility table. And so what we did, scientists did this one right here. What scientists did is they went and they took a whole bunch of ionic compounds and they tested it to see what would dissolve and what wouldn't. And their results were this table. So you don't have to do the experiment. It's already been done for you. Here's how it works. Up on the top here is a group of ions. Okay, so all these different ions, both positive and negative, mostly the negative one. And what it shows below is solubility greater than or equal to 0.1 moles per liter. What that's saying is that it's really soluble. It'll dissolve really easily, okay? And then we've got this other section of solubility less than 0.1 moles per liter. So that's saying that it's not going to dissolve easily. And so what we do is we find the ion along the top and then we find the matching part of it. And from there we can make a decision. Is that thing going to dissolve or not going to dissolve? So let's try a couple here. I've picked a couple here that don't dissolve. So let's start with this sodium hydroxide, okay? Sodium hydroxide combined with silver nitrate. And you notice that when you mix those two, we get this like milky brown precipitate, this thing that's not dissolving. And so what I did is I went through this one. Let's make sure that's working. And this one, nope. Let's try that again. Here, yay! All right, so on the iPad, I've written out, so we've got aqueous sodium hydroxide and liquid silver nitrate. Now, in a lot of these scenarios, we are going to give you some of the reactants. So notice, in here, I just want to highlight it for you quick. I gave you aqueous sodium hydroxide, and I should actually probably change this. I changed it last minute. This is aqueous silver nitrate. Okay, so we gave you both of those. So as we write our equation, I included both of those there. Aqueous sodium hydroxide, which is our base, and silver nitrate, both aqueous. What we want to know is we want to be able to predict the states of these two guys. Now, looking at this reaction, we think that one of them is going to be solid, right? Because we end up with this solid precipitate as we mix the two of them together. So we need to figure out which one is going to dissolve. So we're going to need two things. We're going to need our table, which we've got right here. So I went and grabbed the table. We've got our table right here. I'll just put it over here, and actually let's make it just a little bit bigger here. Beautiful. I'll cover up the next question for now. Okay, so we need our table, and we're going to need probably our periodic table. Now, I wrote out the reaction for you. In the future, you're going to have to write your own reactions, but we'll get there. I wrote out the reaction. We need to predict both of these guys here. We need to predict whether sodium nitrate is going to be a solid, and this silver hydroxide is going to be a solid. Okay, so we've got two options here. What we need to do is we need to look at what makes up each one of these things. So making up this guy, we've got sodium. Let's do this in red here. We've got sodium. Okay, we know that that is a +1 charge. We've got nitrate, NO3 minus. Okay, that is a -1 charge. Now on silver, we've got our silver hydroxide. We've got silver. Okay, silver is a +1 charge. And you can find that by going to your periodic table. So let's do that quick. Okay, here's silver here. We see that silver is a +1 charge. Okay, so that's where we're getting that information from. Hydroxide here is a 1- charge right here. All right, so let's go back to our problem here. And so we've got, we've got OH minus. Now, what we need to do is we need to find these things on our periodic table. And what we're going to do is we're going to look at the combination. So let's start with this NO3 minus. So here's our NO3 minus right here. Okay, so there's our ion right on there. Now, most of the time we're looking for the negative ion, the anion, but let's just highlight it here. So here's our NO3. Now we go down our chart and we see exactly what it says. So here we go. We're going down. So let's start with the none part because that just makes the most sense. So this part here says none. What that means is when combined with none of those ones, it won't dissolve. So all of them, all of the substances that NO3, nitrate, is matched with are going to result in a solubility greater than 0.1 moles per liter, very soluble, which means it's going to dissolve. And so what we're going to end up with is, because we've got this substance that is dissolved in our solution, we are going to call this aqueous. All right? All we did was we saw which category this met up with. So our sodium, okay, fits into this all category here. And now we know that it is going to dissolve. So let's look at it. It must be silver, but let's prove it. So now we're going to go to our OH. Let's get rid of these here. Is that working? Nope. Don't know why it's not working. Oh, there we go. All right, so now we're going to go over to our OH. There's our OH there. Now, what we're trying to do is we're trying to figure out which category silver, the thing that it's matched up with, fits into. And so let's take a look. Does silver live in group 1? Well, the answer is no. Silver's not in group 1, so that one doesn't make sense. Ammonium, strontium, barium, none of those are silver. And so it must be in one of these guys. Well, most of them means that its solubility is less than 0.1, which means it's going to form a precipitate when mixed in water. And so this guy here is actually going to be solid. And that's what we're seeing in this slide right here. We see sodium hydroxide and silver nitrate. What we're seeing there is that silver hydroxide, that's the brown stuff that we're seeing as those two mix together. That's our precipitate, and so it is solid. All right, let's do another example here. Move this up here. Let me just bring it to the front so it's over top of everything else. There we go. All right, so now this next one that we've got sodium hydroxide, I chose that one again, and cobalt-2 chloride. So what I've done here is I've written out both the formulas. And I said we're going to do it as liquid cobalt-2 chloride. It's probably aqueous, but I'm just the idea is that we're giving it to you on this one. So sodium hydroxide in its aqueous form combined with cobalt-2 chloride, so there's the thing that makes it cobalt-2. That little 2 below, that just goes back to writing ionic formulas. Here, sorry, you guys can't see anything I'm seeing right now. My bad. There we go. All right. So sodium hydroxide here, cobalt 2 chloride here. And so now what we want to do is we want to predict the states of these here. So we're going to end up with sodium chloride, which is salt, and this cobalt hydroxide. And so that's what we need to predict right now. So same thing. We're going to look at NaCl first, sodium chloride. And so we're going to look, here's our chloride. There's our anion right there. So chloride's right there. And what we're saying is that most of them that are combined, most of the ions that are combined with chloride are soluble, dissolve. And so we're looking for the exceptions. And we're seeing if sodium is one of those exceptions. So I look silver, no, none of those are sodium, so that means it falls into this category. And so what we're going to get is we're going to get an aqueous, that was so bad, aqueous solution there, okay, because it wasn't in there. Let's go to our cobalt hydroxide. So we find our hydroxide here, and we're looking for cobalt. So cobalt here, nope. So most of them will not dissolve, which means we are going to get a solid. And that's what we see here in this precipitate that's floating in the middle of this reaction here. This is cobalt 2 chloride. And so just by looking, here's one that's unnamed, but you can see a precipitate forming as those two chemicals mix together. So what I want to do right now is I want to show you guys a couple of really quick examples here. So what's going to happen is I'm going to name one, I'm going to pause the video, and you're going to try it. And you're going to try it using your solubility table. So the question here says this: determine whether the following iconic compound have a high solubility or a low solubility in water. So we're going to start with this one, KCl. The video is going to pause right here for you guys to try it out. So KCl, ready, go. All right, so you've tried it. Let's see how we would approach this. So our two ions in here are potassium and chlorine. Okay, so we've already done this guy once. We look down here. This is chloride here. Okay, I find it on my thing. Let's move it so you can see it past my face there. Make it a little bit bigger as well. Okay, so we've got potassium and we've got chloride. Our chloride here says that most of them are going to dissolve in water with the exception of these 5 down here. Now, potassium is not one of those 5. So that means that we are going to have a high solubility. So our answer for this one here is going to be high solubility, which means which means it's going to dissolve in water. All right, let's try the next one. So number 2, or letter B, SrSO4 minus. Ready? Try it now. All right, so let's try this next one together here. So our formula, we've got Sr, strontium, which I believe is a 2+, but let's just look it up here. I just don't know off the top of my head. Sr is a 2+ here, and we've got SO4, which is sulfate, so strontium sulfate, which is a 2-. That's this guy right here. So both of them carry a charge of 2-. So we've got Sr 2-, and we've got SO4 2-. So what we need to do is we now need to go to our solubility table. All right, so let's rip over to our solubility table. We're probably looking for our anion, and so here it is here. Here's our SO4 2-. Now, we go down on here, and we find out that most of them have a high solubility, with the exception of calcium, strontium, barium, radium. Look at all of those 2+ ions and then a silver down there. So we see the one that we're combined with right here, this strontium. So what does that mean? Well, that means that officially this guy has low solubility. Low solubility, all right? So that particular substance has low solubility. All right, let's try this next one. So now we're going with this guy, ammonium hydroxide, NH4+, OH-. Ready? Pause now. All right, so let's do the math on this guy here. Let's see what we got. So we've got NH4, 4, which exists as a plus, and we've got OH minus. So let's look here. With this one, we can have both. We can look at both the NH4 plus ion and we can look at the OH minus ion. So let's just see if they match up. We're going to go NH4 first. All of the ones with NH4 have a high solubility. Let's look at OH. OH, high solubility, look at it, matches. NH4 is right there as well. So we can say with a ton of confidence that this guy here has high solubility. All right? Let's do one more in this section and then we'll keep moving. Copper chloride, okay? We know that this is copper 1 chloride because, ooh, that's not erasing. Let's go like this. Here, here, here. Perfect. So we know that this is copper 1 because chloride is a 1 minus charge. So based on our formula, this must be a 1 plus charge. All right, so now we want to see, will this dissolve? So let's go take a look here. We go down here, we find chloride in our table. We scroll down, most of them it dissolves in with the exception of these 5. Look at copper 1 plus is there. So this has a solubility of less than 0.1 moles per liter, which means that it has low solubility. So our answer for this one is low solubility. So what I want you to do now is I want you to try these next 4, okay? These next 4 here. So question number 2, these next 4 right here, I want you to give those a try. I'm going to pause the video now. We'll come back to it in just a second. Ready? Go. All right, so hopefully you've had a chance to try these ones. If you had any questions, I'll post the answers online. So that you guys can fiddle around with it. At the end of this video, I've attached a sheet just for practice, okay? It's just one of those things that we just have to practice going back to our solubility table. So that should wrap up solubility. Starting next week, we'll talk all about the types of reactions, balancing reactions, where now we're going to get you to write your own reactions and predict what we're going to experience. So hope that was helpful. If you've got any questions, jump on a tutorial with me. And we'll talk soon. Okay, bye.